We've written some regular expressions in this course, and you'll most likely use it in most projects to check if a certain input is in a format you want or match a combination of characters. So you need to understand how to write a secure regular expression. Regular expression denial of service can happen when you have a vulnerable regular expression, also known as evil regex, on which regular expressions may take exceptional time to execute a certain input. When you compute an evil regular expression, the event loop will be busy matching the given string, and your server will deny the services to requests. Evil regex, or evil regular expression, usually looks like this: a regular expression with nested operators. I have written a blog on regex denial of service that explains what it means and how it works. You can read it for more. I gave an example of a vulnerable regular expression and demonstrated how it can block the event loop. I will probably include it as an article on Udemy as well. So let's see this in practice by first creating a regular expression that matches with a string that starts with a letter, any letter from A to Z, and should have more letters and then contain anything. That's what the dot is representing. And it should also end with a capital or small letter. I enclosed it with braces and I added a plus, meaning it should be more than one of the enclosed characters. Finally, it should end with more than one upper or a lowercase character. So it contains an evil regex since it has nested operators. So let me define a string to test the regular expression. So strings have a match function that takes a regular expression to check if it's a match. Okay, let me run it now. It's returning null since the past string doesn't have any match. So let me change it to a string that matches the pattern. Here you can see that all the matches found are returned as an array. Now let me generate a value that can cause regex denial of service or block the event loop. So I'm going to use this for loop of length 100 to form a string of 100 A characters. And at the end of the string, I am going to add an exclamation mark. This produces a combination of 100 A's and concatenates with an exclamation mark. And instead of an exclamation mark, you can also use any characters other than a letter. Let's clean up the terminal first and execute the code. Looks like we got an error. Let's see what it is. So this should be let instead of const. Now you can see that it hasn't logged anything since it's blocked. That is because the regex engine has a feature called backtracking, where if the input fails to match, the engine goes back to the previous position where it could take a different path. It tries this many times until it explores all possible paths, consuming the event loop to take an excessive amount of time. Let's add a simple console log here to see if it is still blocked. It's the same, so to protect this from happening, you need to be able to identify an evil regex, and there's also a package that can help you with that. The package is called SafeRegex, and it returns true or false depending on the regex safety. So let's install it and check if the regular expression is safe or not. Okay, let me import it first, and I will show you how it works. So let me console log the safe function by passing the regular expression. let's comment out the rest of the code and run it again. It is logging false since this regular expression is vulnerable, and if it was safe, it would have returned true. So you can simply check your regular expressions with tools like this before using it.